Okay. Okay. So in last semester we started with engineering mechanics, and then the specific section of engineering mechanics that was engineering statics. We studied that in our last semester, and then in current semester, basically we are about to study. We have started studying the second portion, which is engineering dynamics. And what is basically engineering mechanics? We have been through it in the last semester as well as in initial 2 weeks. So the topic, the major topic that we have to cover today, it's basically kinematics of particle. But before going through it, let's have a revision of our previous concepts. Okay, engineering mechanics, as we already know, it's the effect of forces uh, acting on a body. So the effect might be in state of rest, or it can be in state of motion. So if the net effect of force is causing the object to stay in its position or in a state of rest, so in that case we will be having statics, or we will consider it as a case of statics. But if the forces are causing the object to move, or it is causing some motion, it is producing some motion in the object, so in that case it will be the case of dynamics. So in dynamics, then we can have two subcategories. One is kinematics, and one is uh, okay. So one is kinematics, and one can be kinetics. So in case of kinematics, basically you can say that in this case we are basically concerned with the geometric aspect of motion. For example, the relationship between the displacement, velocity, and acceleration. Okay. However, in case of kinetics, we are concerned with the relationship between these type of motions and also the force which basically causes that motion. So in kinematics, we do not consider the force or the forces which basically causes motion, whereas in kinetics, we do consider the force and its relationship with the motion. Means the effect of force is basically motion, but we also consider the force. So in dynamics, we can have these two portions. So in today's class, what we are going to do, we will go through kinematics of particles. So we can have kinematics of particles, and then in second case, like we can have kinetics of particle. Then we will be having kinematics of rigid bodies, and then kinetics of rigid bodies. Okay, so as I have told you earlier, that kinematics is basically concerned with the geometric aspect of motion, that is displacement, velocity, and acceleration. And usually we measure these quantity with respect to time. Okay, all these quantities are basically vector quantities, but over here I have represented them as scalar just for simplification purpose. Otherwise, displacement, velocity, and acceleration, all of them are basically vector quantities. Okay, so imagine that we are having an object, a body or a particle at uh, initial state or at time t is equal to 0. So after some time, the sometime t, it gain this position, and let's say that the distance that it cover or the position that it have, it is s. Now during a differential time or during a small interval of time, it covers further distance dt. So the differential time is basically t plus dt, and the distance that it covered during this distance means from t to t plus dt, or from during this time interval dt, let it be represented by ds. Okay. So usually the velocity, we already know that velocity is basically the rate of change of displacement. So means simply we can write it like ds by dt, the rate of change of displacement. Why we are writing this ds by dt, and sometimes we write it at delta s. So we will get this point in our coming slides. Okay. So we already know that acceleration is basically the rate of change of velocity. So we can write it this way. Since v is basically equal to ds by dt, if I put this thing over here, so we can get this equation. So this means we can also say that acceleration is basically 2 times derivative of displacement with respect to time, a double derivative of displacement with respect to time. So these are very basic things which we already know. In dynamics, basically we are concerned with the motion, and we are concerned with the effect of forces, and as a result of effect of forces, what we basically get, we get motion. So the motion produced, it can be of different type. It can be a rectilinear motion, it can be curvilinear motion, or it can be a circular motion. So we will consider each case separately. Now, what is motion? So we will say that a body is in motion, or an object is moving if it is observed from a fixed reference, if it is observed from some fixed reference and the object is changing its position. For example, if you are standing by a roadside and a car is moving, so now in that case you are at a fixed position and the car is changing its position with respect to your origin, or with respect to the reference. So in that case, since the position is changed in a certain time, that's why we will say that the car is having some motion. So a body or object is said to be in motion when it is observed moving or changing position relative to a fixed reference as time passes. So here we have used this word position. Now to define a position, for example, if we have this coordinate system, for example, if this is the object, if this is the object or this is the object, now to locate the position of this object or this particle or body, what we need to do, we need to have some system, and usually the system which we use to locate the position of this object, that is coordinate system. So we can have different coordinate systems. So in coordinate system, what we do, we basically define some reference, some origin, and then we use some variable, for example x variable, and for example some y variable. And if it is in 3D, so we can use a third variable. So if it is linear, then we have to use linear coordinate system, for example x y z. And if it is having some angular distance or some path involved, so in that case we can use polar coordinate, spherical coordinate, and cylindrical coordinate. Now what are polar coordinates, cylindrical coordinate, or spherical coordinate? We have already discussed these things in our previous lecture as well as in our uh, last semester. Okay, so to define this position, what we will do, we will give the value of variable. If we have these values, so we can easily identify this position. Now, if this is the fixed position, fixed reference, and the object is moving its position with respect to time, so this is the next position. Now, if you want to find out how much distance has been covered during time, so what we can do, we can find the change in position or the distance that it covered during this interval. So from here, basically, we can find out, or if it is moving, it is changing its position. So we'll say the object is having some motion. Okay. Now, distance. What is distance? Distance basically represent that how far an object can travel, or how far object travels. And remember that it does not depend on direction. Whereas displacement, it basically depends on direction. Okay. So displacement, how we can find out displacement? So it is very much easy. Like what you need to do, if this is the final position, if this is the final position, if this is the initial position, so what we have to do, just subtract final position minus initial position. Okay, so you have to subtract initial position from the final, and what you will get, you will get displacement, and usually displacement is represented by delta s. Okay, now in this case, sometimes if we have a straight line motion, for example this is the motion, and this is s1 position, this is s2 position. If this is 1 and this is 2, so in this case, both distance and displacement will be same, s2 minus s1. But if it is like this, so in this case as well as in this case, if this is 1, this is 2. So the distance in this case will be more than displacement. Because if you remember your physics definition, displacement is basically shortest possible distance between 2 points. Now, let's consider another case. We start our motion from here. The object covers some distance, then it moves like this, and then it reaches this position. Now, in this case, the starting and the ending point are same. So displacement in this case will be 0, whereas the distance it travel, it will be basically the path that it covered. Okay, so how we can find out displacement? It will be just simply final position minus initial position. Okay, speed, it is basically the rate at which object is moving, and mathematically we can write that it is basically the distance covered in certain time or distance by time. Since distance is basically a scalar quantity, so speed is also scalar quantity, means it does not depend on direction. Whereas velocity is a vector quantity, means it need direction. So we can say velocity is basically speed with direction. Since it is a vector quantity, this means we cannot use this distance. So this will be displacement by time. And for displacement over here, we are using delta D. It has magnitude as well as direction, since it's a vector quantity. Now, what is magnitude? Magnitude is basically a measurement that has some certain value. For example, kilogram, for example, meter. Okay, screen is not showing to me. What you need to do, आप जाके अपनी जो मेरा नाम है जहाँ पे स्क्रीन शेयर हो रहा है उस पर क्लिक करके, ठीक है, उसको पिन कर दे तो फिर आपको स्क्रीन नजर आएगी। सिर्फ इनको स्क्रीन नजर नहीं आ रही है, बाकी लोगों को भी मसला है?
नो सर, हमें आ रही है।
ठीक है, ठीक है। सो आपने किसी और के उस पर क्लिक किया होगा, आप मेरे नाम पे क्लिक करके उसको पिन कर दें। Okay. Now, what is acceleration? We already know that acceleration, again, it's a vector quantity and it's the rate of change of velocity, means change in velocity in a given time. Okay, so usually the velocity or acceleration that we use, it is basically known as average acceleration or average velocity. ठीक है? Okay, so average velocity or average acceleration, but in for sometime for our calculation purpose, what we basically do, we try to find out, or we try to use instantaneous acceleration. If you look at this word instant, instant mean acceleration at a certain moment, acceleration at a moment. This means acceleration during a very small interval of time. And sometime to represent that small interval of time, what we basically do, we use this term delta t turns to approaches to 0. Okay, sorry, I'm actually using my mouse pad, that's why the writing is not that good, but I hope that at least you are getting my concept.
Yes, sir.
Okay, so when delta t approaches to 0, at that very small moment, the change in velocity will be known as instantaneous acceleration. And similarly, the change in displacement, or the displacement per unit time, when delta t is approaches to 0 or during a very short interval of time, that is basically known as instantaneous velocity. So for instantaneous, what we will do, the change in velocity will be represented by differential term dv, since it will also be very, very much small. And definitely the time will also be represented by dt. Okay, position. So if some particle is moving in a straight line, we will say it is having a rectilinear motion. So at any given point, if you want to find out the position, so what we can do, for example, the object currently at this position, let's say the point is P. If you want to find out the position of this point, the object or the particle P, so what we can do, the first thing that you will do, you will set some reference point, some origin. And since it's a linear or rectilinear motion, so then what you need to do, the origin should be on this line. Then you will set your reference. After reference, what you will do, you will set the positive and negative, that object is moving in this direction, it is positive. If object is moving in this direction, it will be negative. So you can set it opposite way. So it's up to you. Once you do it, then what you will do, you will measure the distance between this point and this point. And how you can do, the coordinates of this point and the coordinates of this point, you can subtract this coordinate from this, so you will get the exact value that where the object is standing at the moment. So I have mentioned the same thing over here in these paragraphs, in these bullets. Okay, so at any given instant t, the particle will occupy a certain position on the straight line. Let's say this one. To define the position P of particle, we choose origin O on the straight line and positive direction along the line. We measure the distance from O to P and record it either as plus or minus according to whether P is reached from O by moving towards right or by moving towards left. So if it is moving towards right, if you can find out the position of P by moving towards right from origin, it will be positive. And if it is observed on the left side, then it will be negative. Okay. So the magnitude, since position is scalar quantity, it has only magnitude. The distance is scalar quantity, it can have only magnitude. And for magnitude, we can use both system, SI system as well as foot pound system. So in foot pound system, the unit can be a foot. Sometimes we can also use inches. and in SI system we will use meters. Displacement. Okay, so displacement, as we already know, it's the difference between final position and initial position. Imagine that we are having particle at certain time t, it is having this position s. Now after time interval delta t, it changes position from p to p dash. So the position of p dash, let it be delta s. So to find out how much displacement it has covered, delta s will be basically equal to s bar final position minus initial position. Now if this s bar, if it is greater than s, so in that case displacement will be positive. But if this one is less than this one, if s bar is less than s, so in that case displacement would be negative. Now let's consider the velocity. So imagine we are having a particle at time interval t1, the position is s1. At time interval t2, the position is s2. So the displacement that it covered during time interval t2 minus t1, it is basically s2 minus s1. So average velocity can be identified displacement within given time. So how to find out displacement? Final position minus initial position, and during the time interval t2 minus t1. If you want to find out the instantaneous velocity, so for instantaneous velocity we already discussed, delta t will approach to 0. So instantaneous velocity will be represented by just simple v, and it will be the differential displacement divided by the small interval time, which is the differential time. Okay, so velocity as is depend on the displacement, and it is a vector quantity, and displacement is also vector quantity. So velocity will be positive if displacement is positive, and velocity will be negative if displacement is negative. Okay, now let's look at the acceleration. So acceleration, we already know it's the rate of change of velocity. So let's say a particle at certain time t1 is having velocity v1. If it is moving with a velocity, certain velocity, let it be v1. Now at after some time interval, let's say at time interval t2, at instant t2, the velocity of object become v2. So v2 can be greater than v1, and it can be less than v1. So now to find out the average acceleration, what we need to do, we need to find out a change in velocity, and it can be identified by v2 minus v1, and the change, the time during which change take place, let it be t2 minus t1. Okay. Now, if you want to find out the instantaneous acceleration, means the change in velocity during a very short interval time when delta t approaches to 0. So in that case, acceleration will not be considered as average. It will be just simply represented by a, and that will be equal to dv by dt. And we also know that this can be further uh, modified by putting v is equal to ds by dt. So we can get d square s by dt square. Okay. So over here, if the final velocity v2 is greater than v1, so in that case, the change will be positive. Acceleration will be positive. If the final velocity, if it is less than the initial velocity, so the change will be negative and acceleration can be negative. So now you can see from this curve, from this arrow, the initial velocity is greater and the final velocity is smaller. Means the object is slowing down, its velocity is decreasing. So usually for positive acceleration, we use the word acceleration, and for negative, when the value is negative, so we use another word which is known as deceleration. So both is basically change in velocity per unit time. Okay. So over here, the velocity is increasing. If you look at this one, so the acceleration is positive. Now in this case, initially we have more velocity and then the velocity decreases. So we can have acceleration, but that acceleration will be negative. So we will use it as, means in this case, the acceleration will be termed as deceleration. That is given over here. The unit that we use for acceleration in SI system, it will be meter per second square. And in case of foot-pound system, it can be foot per second square. Okay. Hopefully, up till now, whatever I have told you, it will be clear to you people. If you are having any problem in it, you can ask me. Okay, if
No,
you
sir.
don't ask, I will consider that you are okay with it. Okay, so the three basic kinematic equation which we will use throughout our kinematic course. So they are basically given over here. Now let's go through these equations. We already discussed that velocity is basically the rate of change of displacement. So this is very simple equation. Okay, and acceleration is the rate of change of velocity. Okay, now let's do it this way. If I take this dt over here and this v over here, so what equation we will get? जी, equation क्या बन जाएगी?
D- dt is equal to
dt.
ds divided by v.
Okay, very good. Now let's say I move this dt over here and dA over here. So what equation will I get?
Dt is equal to dv by a.
dv by
We divide by a.
Okay. Also now in both equations, we are having the term equal to dt, right? So this dt and
Yes,
this
sir.
dt, since both are dt, we can equate them. ds by dv, ds by v and dv by da, both are equal to dt, right?
yes sir.
Okay, take a here and v here. So when you do it, what you will get? You will get another equation a ds, which is equal to v dv, right?
Yes sir.
Okay, so these are the three basic equation which will be used for your calculation for your problems throughout this chapter or throughout your kinematics course. Okay, I think it's very much easy to memorize these equation, and they are nothing to
Yes.
memorize. If you are having
Yes,
basic
sir.
concept of displacement and velocity and acceleration, so you can write down these equation anytime. Okay, let's have a problem. The velocity of particle moving along a straight line, so means rectilinear motion, is given by this equation, where t is in second, m is meter, and s is second. So t is in second. If the position s is equal to 0 when t is equal to 0, this means at time t is equal to 0, the position at which the object is, that is 0. So determine the acceleration and position when time t is equal to 4 seconds. So first, what we need to do for every question, as I have already told you people, you have to mention the given data and then the required data. Then after this, you need to draw the diagram or free body diagram, whatever is possible, in case if it is possible. Then the solution, and solution we have to put the supposition if there is any. Okay, so let's see the given data. So when t is equal to 0, s was 0. And what is required? When t is equal to 4 seconds, we need to find out the position and we need to find out the acceleration. And this is the equation given. So we already know we are given with velocity. We are given with velocity. Okay, let's say if you are given with displacement and if I ask you to find out velocity, so how you can find out velocity?
टाइम पे डिवाइड कर
टाइम पे डिवाइड करें या डेरिवेटिव ले लें?
Derivative
यस सर
value.
वही डेरिवेटिव
ओके, ठीक है, डेरिवेटिव आप उसका ले लें. ओके, लेट्स डू इट रिवर्स. अगर आपको वेलोसिटी गिवन है, मैं आपसे कहूं पोजीशन फाइंड आउट करें, फिर डिस्प्लेसमेंट फाइंड आउट करें,
फिर
देन
v के साथ
इंटीग्रेट
फिर v के साथ dt करेंगे
देन
इंटीग्रेशन.
इंटीग्रेट करते हैं, रिवर्स में आ जाएं. ठीक है, नाउ यहाँ पे क्या मांगा गया? एक्सेलरेशन मांगी गई है, तो वेलोसिटी को हम क्या करेंगे? इसका डेरिवेटिव ले लेंगे. फिर यहाँ पे
Yes.
क्या कहा गया आपसे? ये पोजीशन फाइंड आउट करें, इसका इंटीग्रल ले लेंगे.
Yes, sir.
ठीक है, और इन अदर वर्ड्स for means for displacement we will use this equation, and for acceleration we will use this equation, right?
Yes, sir.
Okay, so as we are having this equation, a is equal to dv by dt, let put this v is equal to t square plus 2t. इसका डेरिवेटिव जो आप लेंगे तो आपके पास आ जाएगा 2t plus 2. ठीक है, I hope that you understand how we get this 2t plus 2,
Yes, sir. Yes, sir.
right?
Yes, sir.
यस
Okay, so since we need to find out the acceleration at t is equal to 4 seconds, so when you put this t is equal to 4 seconds, we will get our required acceleration value. Okay,
Yes,
so
sir.
now we need to find out basically the displacement. So displacement, what we need to do, we can integrate this equation with respect to time. Okay, so it can be done like this way. You take this v over here, so it will be v dt is equal to ds. So v dt, instead of v, you put the equation t square plus 2t, dt will be as it is, and ds will be on this side. Now you need to integrate it with limits. So what is the limit? For time, the limit is 0 to 4, or t is equal to 0 to t, right? And this t is basically equal to how much? 4 seconds.
Yes.
Okay. Okay. And for position, the starting position s is equal to 0, and the final position basically we need to identify. So let's s is equal to 0 initial, and this s need to be identified. Okay. So when you integrate this one will become t cube by 3, and this one will become 2t square by 2. 2 will be cancelled out, and we will get this equation. And over here we will get s when you put limit. So it will be s is equal to this thing, right?
Yes, sir.
Okay. So at s is equal to, at t is equal to 4 seconds, we need to find out the displacement. So put t value in this equation and get your desired displacement at t is equal to 4 seconds,
Yes, sir. Sir, upper
right?
menu value minus lower value like this.
Upper
So
value minus lower value means,
means higher. So when we integrate, for example, with a value, with a
J,
value
J, J, J,
below.
J, upper, yes, yes, exactly, yeah. So you have to put upper limit, upper means the final position at top and the initial position at the bottom of limit. This is what you are asking?
Yes, sir. Yes, sir. In
J, J,
case
exactly,
in your initial position is not 0.
yes, in case initial position is not 0, then in that case, for example, if initial in time interval was 1 second, so you need to put t is equal to 1 in this case. If the initial position was not 0, then you need to put exactly the initial position over here. So in coming problems, we will observe case where the initial position or initial time is not 0. Maybe initial time is 0, but not the initial position. So we will look into it. Okay.
Yes, sir.
Okay. Now let's go through the second example, the acceleration of particle moving along a straight line. Again, rectilinear motion. A is square root s, meter per second, where s is a meter. If s is equal to 0 and velocity is equal to 0 at t is equal to 0, this means when time t was 0, velocity was 0 and s was also equal to 0. So what you need to do, you need to find out the velocity when s becomes 16 meter. And what they basically asking, what time is that? So in other words, what you need to do, when initial condition, boundary condition was given that t is equal to 0, and at when t is equal to 0, so s and velocity was also equal to 0. What you need to find out, when s is equal to 16 meter, you need to find out the velocity and what was the time at that, means at what time s can be 16 meter. So you need to find out the velocity and time. Okay, so we are having three basic kinematic equation. This one, remember, we have a is equal to square root s. Okay, so we either need to use this equation or this equation. In these two we have to use one. If I use this one, if I put under square root s dt, right? So in this case, what will be the equation, means it will be under root s and dt. So in this case I will get limits with respect to time. So I have just one time limit and I don't have the other time limit, right? And I also don't have the value of s. So both are unknown. You see, this is unknown, this is unknown. Let's try another equation. This one, if I put a as square root s, a is equal to square root s, and that will be equal to v dv. So in that case, when I put the limit, this limit s is equal to 16 and s is equal to 0, so I will be in a position, to find out this velocity, right? Okay, if I do it this way, so if I use this equation over here, so with this I might be in a position to find out the time because s is given over here, right? So it's up to you. If you want to find out, the time, so use this equation. If you want to find out uh, the velocity, use this equation. So you can use any of the equation, it's up to you. So what they are asking for, they are initially asking for velocity, so let's use this equation. Okay, Are you people getting me?
Yes,
Yes,
sir.
sir.
Okay, so we have this equation a ds. So let's this a be equal to square root s ds and v dv be as it is. Put integral on both sides. So the integral or the limit is 0 to 16, 0 to 16, and over here the limits is from 0 to we don't know the final value. Let it be v. Okay, so square root means 1 by 2 in power, right? So 1 by
Yes,
2
sir.
in power, when you integrate it, so you need to add 1 in the power, which 1 will become 3 by 2, and the same divide in the bottom, right? So when it goes upward, it will become 2 by 3 and is s 3 by 2. And over here, it will become 1 plus 1 v square by 2.
Yes,
Okay, so v square by 2. So when you take this 2 over here, this one will become 4, right? And this one will become v square is equal to 4 by 3 s 3 by 2. So now you need to take square root. When you take square root, you will get this value. So
Yes,
when
sir.
s is equal to 16 meter, so what you need to do, you need to put s over here and you will get your velocity value, right?
yes,
Now, okay.
Yes, sir.
Now what we can do, we can use this equation or we can use this equation. So we are having option for both one. Let's use this one. We need to find out time. Okay. So v is equal to basically ds by dt. So let's use this equation. V is equal to ds by dt. So for velocity, instead of velocity, I have used this equation, which I just told you, this one. Okay. So velocity is equal to this and ds by dt as it is. Let dt be moved here. So dt is equal to under root 3 by 2. Okay. How we simplify this one? This is square root 3, square root 3. Can I write it this way?
yes, sir.
Okay. So 1 will be
Yes,
cancelled
sir.
out with this one. So when it goes on the other side, it will be under root 3 by 2, like this one. And this s3 by 4, it will become minus s3 by 4 when it moves here. And this will be ds. Okay, so you need to integrate it. So when you integrate it between time limit t is equal to 0 and t, this is basically need to be identified. Initial position is s is equal to 0, final is 16. So we will get this equation. Okay, what we need to do, we need to find out the time interval when s is equal to 16. Put s is equal to 16 here, and you will get your required time. Okay,
Yes, okay, sir.
now example 3. Okay, remember in today's class, whatever I am teaching you, it's from your book RC Hibbeler. So same content has been given in JL Merriam book, dynamic JL Merriam book, and in RC Hibbeler. So RC Hibbeler chapter 12 onward, that portion is basically related to dynamics. Okay, so it doesn't matter whatever book you follow and whatever edition you follow. uh, you can do problems from RC Hibbeler, you can do it from JL Merriam. Both will give you the concept, and the same concept can be utilized in your exam. So sometime I will use JL Merriam, sometime I will use RC Hibbeler. So you can also use any of these two books, and both books are basically uploaded in Google Classroom. Okay, the car in this figure 12.2, 12.2 means like it is chapter 12 of RC Hibbeler, and figure 2 moves in a straight line. This means rectilinear motion for a short time. Short time means when delta t approaches to 0. So we need to use the ds or by dt equation, something like this. Okay, the velocity is defined by this equation, and the unit is foot per second square, where t is in second. So what you need to do, determine its position, acceleration when t is equal to 3 seconds. Okay, initially when t was 0, s was also equal to 0. So again, the boundary condition, the initial conditions are given. When t is equal to 0, s was 0. What you need to do when t become 3 seconds, you need to find out the position, you need to find out the acceleration. So it's very much self-explanatory. You are given with velocity. So what you need to find out, you need to find out the acceleration, take its derivative, you need to find out its position, take its integral. Okay. So let's say we need to find out the position. Initially, they are asking for position. So let's use this equation. ds will be equal to v dt. For v, put this value. V is equal to ds by dt. So put V value over here, take dt over here and ds on the other side. So when you put the integrals, it will be like this. Try to find out the integral. It will be t cube by 3. 3 will be cancelled out. 2t square by 2. 2 will be cancelled out, and you will get this equation. Okay. When you put, okay, so this is the final equation. When you put t is equal to 3 seconds, so this is the equation that we will get. And this is the answer, 36 fold. Now you want to find out the acceleration. So again, acceleration is the rate of change of velocity. Over here, put velocity value. Okay, so instead of v, we put the velocity value of take its derivative. So when you take its derivative, it will become 60 and this one will become 2. So when you put t is equal to 3 seconds, what you will get? You will get your required acceleration value. Right?
Yes, sir.
Okay. Now rectilinear motion with constant acceleration. Rectilinear motion with constant acceleration. Now this is this means when you are having constant acceleration. For example, you are having an object. For example, you throw the ball upward. You are having a ball and you throw it upward. So initially it is having some velocity, and as you throw it, it will be having a very high velocity. As it move upward, its velocity will increase or decrease.
Decrease.
Okay, the velocity is decreased. Then as it is moving upward, the velocity is decreasing
Yes, sir.
as the arrow magnitude is showing. Right?
Yes, sir.
Yes, sir.
And finally, the velocity will become
0.
Okay, tell me one thing. Why the velocity is decreasing?
Under the constant
Because
gravity.
there is deceleration.
Why deceleration?
Because of
अब
Due
कोई
to
contract
gravity.
कर रही है
Yes, exactly due to gravity.
opposite
There is a
force.
gravitational force. Yes, it is pulling it towards the ground. Right? So means the velocity is reduced. The velocity change in velocity is due to the gravitational force. Right?
Yes. Yes, sir.
And
Yes, sir.
that force is constant. Right?
Yes, sir.
Yes,
Yes,
sir.
sir.
So the change that it produces is also constant. For example, if initially the velocity over here, if it was 10, and over here it will become 8, in next second it will become 6, in next second it will become 4, then in next second it will become 2, and then might be in next second it will become 0. So the change in velocity per unit time in these two cases is how much?
2 meter.
2. What about this one?
Here also 2.
2, and here also 2. So means the acceleration on change in velocity per unit time is 2. Right?
Yes, sir.
So this is an example of constant acceleration. Okay, what about the acceleration over here, the change in velocity here?
Here also
Same too.
2.
Okay, so sometimes people get confused that velocity here is 10, here it is 4, here it is 0, and we are saying that it's a constant acceleration. So remember, it's not a constant velocity, it's the constant change in velocity. Right? Okay.
Yes.
So now at this position, the velocity is 0, but still the acceleration is 2 meters per second square.
Yes, sir.
Because the change between this instant and this instant is 2. And the moment it comes to rest, so in next second, again, the velocity will start increasing. So change in velocity again will be 2. And then again it will be 2. And all these things, it is basically due to some attraction force. So in case of gravitational field, in case of force due to gravity, the acceleration or the change in velocity per unit time, this will be how much? 9.81 meter per second square. Right?
Yes.
Okay. So a very good example of constant acceleration can be like a free falling bodies. Any free falling body. For example, if you have stone and you throw it from a building, and if you let it to go from top of building towards the ground, so that will be an example of free falling bodies. Right?
Yes.
Yes, sir.
Okay. So again, we are having three kinematics equation, which we just gone through in our previous slides. So now we will consider the constant acceleration case, and by using these three kinematic equation, we will derive three further equations, which you are already aware of, and they are basically famous equations of motions, if you remember. So in our very basic course of physics, we derive these three equations: equation of motion, first equation of motion, second equation of motion, and third equation of motion. Do you remember
Yes.
these equations? Okay. If you can recall any of the equation, याद है कुछ?
VF is equal to VI plus 80.
Okay, Vf is equal to Vi plus 80. So we will derive each equation from, means we will use one equation from here, and with that equation, we will derive one equation of motion. So let's first use this one. A is equal to dv by dt. So in this case, acceleration is equal to constant. So A is equal to dv by dt. Let's move this dt here. So dv is equal to a dt, and A will be equal to constant acceleration. Take its integral. So when you put the integral over here, this is constant. So it will remain as constant. It doesn't have any impact on the integral. So when you try to find out this integral and put the limit, so you will get v minus v naught, and over here you will get ac t minus 0. So you will get this thing. So when you move this minus v naught on the right side, what you will get, v is equal to v naught plus 80. So this is the same equation, which is vf is equal to vi plus 80, right?
Yes, sir.
Okay. Now
Yes,
let's
sir.
use the other equation. The other equation, which is velocity is equal to rate of change of displacement. So now in this case, we have d is equal to v dt, and the equation that we just proved, v is equal to v naught plus 80. Let's put v value over here. Okay. So when you put the integral, the integral will be s naught, and the velocity will be v naught plus a constant acceleration t. So try to find the integral. When you find the integral and put the limit, so it will become s minus s naught, and this one will become v naught t. This one will become half ac, which is the constant. So why this half come? This is basically t 1 plus 1 t square divided by 2. So t square by 2. When you put the limit t and 0, so you will get this thing. Okay. Now, if you remember, I have just told you that displacement, that is basically determined by subtracting initial position from the final. So delta S is basically displacement, and delta S is equal to V naught plus half constant acceleration t square. Or another word, this is the second equation of motion, which we used to recall as S is equal to VIT plus half AT square. Clear है ना यहाँ तक?
Yes, sir.
Okay, so if you want to find out the final position, just move this one over here, and we will get this equation: S is equal to S naught plus V naught t plus half A constant t square. So this is like the equation that we derive. Now let's use the third equation of kinematics, which is A ds is equal to Vd. So put A is equal to constant acceleration and remaining as it is. Put the integrals. The integral we put over here, AC is equal to S minus S naught, and this one will become half V square. Put the limits, V square minus V naught. So what we will get, V square minus V naught square is equal to 2A, and this is basically delta S, if you remember. So
Yes.
this is the same equation as Vf square minus Va square is equal to 2As. So over here, instead of delta S, we basically put S minus S naught. So if you put the initial velocity on this side to find out the final velocity, we will get this equation, right? Which is the third equation of motion.
Yes, sir.
Okay. Now the acceleration, constant acceleration case. So when we use that constant acceleration case, we get these three equations, right? So
जी हम फ्री फॉलिंग बॉडी के लिए देखें
ये constant acceleration के लिए, it can be free falling body or it can be any other case in which the acceleration remains constant. Okay, it can be a car moving with a constant acceleration. It can be a person moving with a constant acceleration, right?
Yes.
Okay, so these are the equation. Remember, these equations are useful only when acceleration is constant. And remember, in first two cases, when we put the initial time is equal to 0, t naught was 0. Or a typical example of constant acceleration motion occur when body falls freely towards Earth. If air resistance is neglected, the distance of the distance of fall is short. The downward acceleration of body when it is close to Earth is constant, and its value is 9.81 meter per second square, or 32.2 feet per second square. Okay, when the distance of fall is short, or when the object is close to Earth, this means when the object is within gravitational field of Earth. If it is too much away from the Earth's surface, so then in that case the gravitational value may be reduced, or the gravitational field might be reduced. So in that case, the value of G can be different. So the close or the short, the term, those two terms which we use over here, short or the close, this is basically just to represent that it should be within gravitational field. Okay. So based on this, let's do this example. Okay. So imagine we have this example. Let's say a ball was thrown straight up in the air from 1.2 meter above the ground. From 1.2 meter above the ground. What they mean basically, when the person, when the machine which throws the ball, at initially at that instant, the position from where the ball was thrown, that was 1.2 meter above the ground, like this one, right? So let's say if we give this position as position 0 name, so in that case the time that we have at that instant, let it be t naught, the displacement or the position at that, let it be this one, 1.2, and the velocity at that instant we don't know that with which velocity he has thrown the ball upward. Okay, now after 3 seconds, the ball returned to the ground. Okay, so imagine when he throws the ball, it went upward, its velocity is reduced, finally it came to 0. So let's say the position where its velocity came to 0, let it be position 1, and then after this start moving back towards the ground. So this is not the ground, ground is here. So when it reaches the ground, the total time that it takes between here till this position, it is how much was the time?
3 seconds.
3
3
seconds.
seconds.
So let's say if this is position 2, so at this instant t2 will become how much? 3 second. And what will be the position? What will be s2 here over here? s2 क्या होगा?
0.
s2 will be 0. What will be v2? What will be v2? We don't know v2.
Gravity.
We don't know about v2 at the moment. We don't know about the velocity due to gravity. So means definitely the velocity over here, at least we know this one. The velocity over here will be how much at v1? जी, यहाँ पे velocity कितनी होगी? 0. We know this thing. Okay, but over here the velocity increasing, and when it reaches near the ground, the velocity will be maximum. How much we don't know. Okay, so what they are asking, let's say this is the initial place, then when it reached this height, and then this one is the final ground position. So what they are asking, determine the maximum height. So what we need to find out?
Distance.
Which distance?
From ground to S1.
Yes, so they are asking for the maximum height. What is the height in this case? G. S1. We need to find out this S1 because this is the highest position. They are asking basically to find out S1. Right?
Yes, sir.
Yes, sir.
Question की समझ आ गई है?
Yes, sir.
ओके, मैकेनिक्स में अगर आपको क्वेश्चन की समझ आ जाती है, पूरी स्टेटमेंट की समझ आ जाती है, तो फिर सॉल्व करना थोड़ा सा आसान हो जाता है. ओके, so now what they are saying, initially when you throw the ball upward, so initially as due to gravitational, initial velocity was more, and then the velocity started decreasing until it reaches 0 at this position. It reaches till this position over here, it becomes 0, and then it started increasing and increasing, right? This was the case. Okay, the change in velocity at any point, that will be equal to 9.81 मीटर पर सेकंड स्क्वायर. ये हमें कैसे पता लगे कि ये 9.81 ही होगा, इससे कम ज्यादा नहीं होगा?
सर वो
ये ग्रेविटी फ्री फॉल.
ठीक है, एग्जैक्टली ग्रेविटी की वजह से. ग्रेविटी एक फोर्स है जो इसमें ये चेंज ला रहा है. ओके, तो 9.81 मीटर पर सेकंड स्क्वायर व्हेन इट इज मूविंग अपवर्ड, व्हेन इट वाज मूविंग अपवर्ड, तो आपके पास वेलोसिटी कम हो रही है, सो इट इज डिसेलरेशन. व्हेन इट इज मूविंग डाउनवर्ड, वी आर हैविंग एक्सेलरेशन, राइट? ओके, सो यहाँ पे देख रहे हैं, इवन तो the ball momentarily come to rest at position 1, means v1 was 0, still we were having acceleration at 1, and that acceleration was due to 9.81 meter per second acceleration due to gravity, and it was downward. It was due to gravitational force actually, right? So यहाँ से हमें एक MCQs के लिए क्वेश्चन भी मिल गया कि आपके पास इवन अगर वेलोसिटी 0 हो तब भी आपके पास acceleration हो सकती है, right?
यस सर.
Okay. So now let's write down the data. Now when T naught is equal to 0, S naught was 1.2, and we don't know about V naught. Okay, when T1 is not given. Okay, at state 1, T1 is not given. S1 we need to find out, but we know that V1 is equal to 0. Okay, as state 2, we are given with time, we are given with the position, but we don't know V2. Okay, and we have this acceleration due to gravity, which is minus 9.81 meter per second square. So we just want to find out the maximum height. So we are having these three equations. Okay, we have.
Excuse me, sir. Sir, T naught will. Sir, T naught 1 के बराबर नहीं होगी. इनिशियल टाइम है तो T naught 1 सेकेंड.
आपसे किसने कह दिया कि 1 सेकंड? जब आप कहीं से स्टार्ट करते हैं आपके पास टाइम 1 होता है या 0 होता है?
नो सर, इनिशियल पोजीशन पे तो 1 सेकंड होगा, उसके बाद टोटल मतलब
1 सेकंड क्यों होगा 1 सेकंड?
सर क्योंकि वो इनिशियल पोजीशन पे नहीं था सर.
अच्छा,
वहां
आप
से शुरू की.
ठीक है, आप अपना स्टॉप वॉच ऑन कर दे, वो देखिए कि 1 से स्टार्ट होता है या 0 से स्टार्ट होता है.
सर वो तो 0 से स्टार्ट होता है, जरी बात है.
ठीक है, तो आपके पास इनिशियल जिस वक्त आप स्टार्ट लेते हैं वहां पे तो टाइम कुछ भी नहीं होता, टाइम गुजरे नहीं होता कोई. So at that instant time used to be 0.
Yes, sir.
ठीक है, and then after that
Yes, sir.
certain interval it will become 1, then 2, then 3.
Okay, sir.
Okay, so now remember, we can use these equation, any of these equation between state T naught and T2, T naught and T1, and T1 and T2, right? So what we need to do, we need to find out S1. ब्रेनस्टॉर्मिंग जरा कर लेते हैं कि क्या कर सकते हैं. S1, let's say if I put this as S1, this one will become S naught. Do we have S naught? S naught, yes, S naught is given. Okay, and this will become V naught T. Do we have V naught? V naught T? Oh, it's not
No,
given.
no, sir. No, sir. No, sir.
Okay, do we have T1? No, it's
No, sir.
so in this equation we don't have V naught, we don't have. Okay, we cannot use this one. Okay, let's look at the other one. If I use this V1 and V naught, so again I don't have I have V1 but I don't have V naught. And over here, so in this equation again, S1 is not given, V naught is a, so I cannot use this equation. Let's look at this one. If I use this one, V1 is given, but V naught is not given, and T1 is also not given. So means 1 and 2 seem little difficult. Let's do it another way. What if we try to use this equation between state 0 and 2? Let's do it this way, because we have S0 and we have S2. Can I use this equation? Let's try.
Yes, sir. We can use it.
Okay, let it be when I use it between 2 and 0. So this equation will become S2 is equal to S naught, V naught T, this one will become T2, and acceleration is constant, minus 9.81, and this one will become T2. Okay, so here we have already have S2 value, we have S naught value, and we don't have V naught value. We don't have V naught value, right? Okay, so I have T2, I have T2, I have AC. So from here I will get value of V naught.
V naught.
सर नीचे वाली
ठीक है,
इक्वेशन से क्यों नहीं लेते फिर?
किससे?
सर ये V इज इक्वल टू V नॉट प्लस ACT, इस तरह तो ज्यादा आसानी से V नॉट आ जाएगा।
किस किस स्टेट के दरमियान? 1 और 2 के दरमियान या 0 1 के दरमियान?
सर आप बोले 0 और 2 के दरमियान लेंगे।
ओके, इट्स अप टू यू, आप ये कर लें। आई एम ट्राइंग इक्वेशंस, यू आर हैविंग एन ओपन ऑप्शन। ठीक है, आप जिससे करना चाहें आप कर लें। ठीक है, सो आई ट्राइड द फर्स्ट इक्वेशन एंड आई गॉट वन अननोन। आई गॉट
यस सर,
वन अननोन। ओके, ठीक है। नाउ as he's saying, if I use this one as v1 is 0 and I use this one as t1, ये आप कहना चाह रहे हैं ना?
और उससे नहीं होगा।
यस सर,
यही नहीं हो रहा ना, यही मैं कह रहा हूँ कि इनके क्वेश्चन के लिए if I use this one as v, let's say it be v2, right, and this one will become t2, so we need to find out v naught. Do we have v2?
नो सर,
नहीं है, तो ये तो नहीं कर, चले 1 के दरमियान अप्लाई कर लेते हैं। if this is v1, this is 0, this is t1, do we have t1?
No, sir.
T1, नो सर,
No sir, so that's why we cannot use this one, right?
यस सर,
Okay, so initially you have to check every equation when you do so many problems, when you have a great practice. So in that case you will be able to directly identify an equation and put it. Okay, what actually I want you people not to memorize these things. I'm doing this brainstorming just to let you people know how to use these equations. ठीक है, otherwise ये तो solve problem है, मैंने तो 5वां सेक्शन है, मुझे जुबानी भी याद हो गया। Okay, now okay, v naught is identified. V naught is identified. Now let's say I want to use again this equation. Now I want to use this equation. How can I use it? If I use this equation as do we have S naught? Yes, we have S naught, and we need to find. Okay, let's use the same equation. The same equation between 1 and 0. This is 1. This is 0. This is 0. This one will become 1, and this one will also become 1. Do we have 1? 1 है हमारे पास?
नो सर,
अच्छा, S1 भी
S1
नहीं।
पे
ओके,
नहीं।
ठीक है, ये इक्वेशन तो रहने दे, ये तो रह गया, ये तो नहीं हो सकता। दूसरा कर लेते हैं। ओके, नाउ इन
T1
दिस
फाइंड कर
केस,
सकते हैं।
और
ठीक
one
है,
और two कर
डू वी
सकते
हैव
हैं।
v1?
One और two.
v1 है हमारे पास।
यस
Yes,
सर,
No. Yes, sir.
डू वी हैव v नॉट?
Yes, sir.
नो सर,
AC भी है।
यस सर,
अच्छा, S1
Yes,
है
sir.
हमारे पास,
नो सर,
S1 नहीं।
वो तो फाइंड आउट करना है। S नॉट है हमारे पास,
Yes, sir.
तो यहाँ से S1 आ
Yes, sir.
सकता है।
Yes, sir.
जी सर,
S1 आ सकता है ना, तो बस ये इक्वेशन यूज कर लेते हैं,
Yes.
इससे हमारा आंसर सॉल्व हो जाएगा। तो हमने क्या करना है, वी विल यूज दिस स्टेट फ्रॉम 0 to 2, दिस इक्वेशन फ्रॉम 0 to 2, and then this equation after this one, this equation from 0 to 1, right? तो हमारे पास आंसर आ जाएगा। ठीक है,
यस, यस सर,
ओके, सो लेट्स डू इट। S2 is equal to S naught, तो ये आप जब करेंगे, what you will get V naught value, and then the third equation, we will use the third equation. When you do it, you will get S1, right?
Yes, sir.
Okay,
यस सर,
so now let's have another example. During a test, a rocket travel upward at 75 meter per second. So usually when you go through a problem statement, so initially some data comes to your mind, so you need to write it on a rough page. So at the end of your reading, that data might not be relevant. Like हो सकता है वो data change हो गया, initial आपकी जो supposition हो सकता है वो गलत हो, लेकिन जो आपके जहन में आता है ना, initially आपको लिख दिया करें। Okay, and then re-verify that data. So initially for the first statement मेरे जहन में जो आया वो ये है कि initial velocity जो है वो 75 meter per second है। When it is 40 meter from the ground, it engine fails. Okay, So let's read it again. During a test, a rocket travels upward. So rocket में engine लगा हुआ है. We have engine inside the rocket. As a result of thrust produced by the engine, the rocket is traveling upward. And with a constant velocity, how much is the velocity?
minus
75 meter.
75 meter per second, right? Means the engine is producing a force which is overcoming the gravitational force, and then after that it is maintaining 75 meter per second. Okay, suddenly the engine fails. Suddenly the engine fails. So आप इमेजिन करें कि अगर रॉकेट आपके पास जा रहा है किसी खास हाइट पे और 40 फीट के या 40 मीटर के डिस्टेंस पे पहुंच के उसका इंजन फेल हो जाता है, सो वो रॉकेट आगे जाएगा या उसी पॉइंट से दोबारा नीचे गिर जाएगा वहीं से?
आगे जाएगा सर।
आगे जाएगा सर जब वेलोसिटी 0 था।
हाँ, तो जैसे ही वो इंजन फेल होगा, ठीक है, इसकी वेलोसिटी डिक्रीज होना स्टार्ट होगी। ठीक है, द डिक्रीज इन वेलोसिटी वो कितनी होगी? 9.81। ठीक है। अच्छा, सो जैसे ये ऊपर जाएगा इसमें 9.81 की कमी आएगी। फाइनली एक खास पॉइंट पे ये पहुंच के इसकी वेलोसिटी क्या हो जाएगी?
0।
अच्छा, वो यही मैक्सिमम हाइट है जो कि ये रॉकेट अचीव कर सकता है, राइट?
यस सर।
आफ्टर दिस द रॉकेट विल स्टार्ट मूविंग बैक टुवर्ड्स द अर्थ। यही होगा ना?
यस सर।
Okay, so what they're saying, this is the diagram. Initially the rocket is traveling upward. When it reached point A, the engine fails, and the velocity at this instant was how much? 75. But then now when it is moving, the velocity start decreasing, right?
Yes sir.
And when it reached point B, the velocity become how much?
0.
0. And this is the maximum height SB. So what they are asking, determine the maximum height SB. Determine the maximum height SB reached by the rocket and its speed just before it hit the ground. So when it started moving backward, when it reached the ground, the point where it hit the ground, that is VC. So the velocity at this instant, VC, it is also required. What is the height at this position?
40.
The height at this position is
0.
0. Okay, so at point A we are having how much height? We are having 40. At point B we are having how much height? We don't know. At point C we have how much height? We basically have this value, which is 0. Okay, so this is basically the given condition. So what we need to do, we need to find out the height SB, and we need to find out the velocity VC. Okay, and what we are given with, VA is equal to 75 meter per second, VB is equal to 0, and acceleration due to gravity is basically minus 9.81 meter per second square, right?
Yes.
Yes.
Okay. So now we are having 3 equations of motion. These 3 equations of motion. Okay, if this is the initial state, we have velocity and we have position. We basically have this velocity, let it be SA, and let it be VA, right?
Yes,
And
sir.
this one will become PA, and this one will be, okay, so can we find out SB? This one will become TB, sorry, not, we don't have TB, right? So cannot use this equation. Do we have TB?
No,
पे time
sir.
given है? Okay, so let's
No,
use
sir.
this one. Let's use another equation. Okay, what if I use this one as VB, this one as A? I am not using this one because it doesn't have S term. Okay, I have A. If I use this as SB and this one as SA, okay, so do we have VB? VB है हमारे पास?
Yes sir.
Yes, sir.
VA भी है.
Yes, sir.
Do we have SA?
Yes, yes, sir.
Yes, sir.
And
Yes, sir.
acceleration, okay, acceleration also. So can we find SB?
Yes, sir.
Yes, sir.
So
Yes,
okay,
sir.
so you use this equation and find your answer, right?
Yes, sir.
Yes, sir.
Okay, now they are asking to find out the velocity. They are asking to find out the velocity at this point.
C.
Okay, so let's use the same equation. Use the same equation. Okay, let's say if I use this equation between B and C, so this one will become C, and this one will become B, right?
Yes, sir.
This one will become C,
Yes, sir.
and this one will
Yes, sir.
become B. Do we have VB?
Yes, sir.
Maybe.
We
Yes,
have
sir.
zero.
SC and
sir.
SB are also there. So can we find out this VC?
Yes, sir.
Yes, sir.
So
Yes,
the problem
sir.
is solved. Okay, I can also apply the same equation between A and C. This one will become VC. This one will become VA. Do we have VA?
Yes,
This
sir.
one will
Yes,
become
sir.
SA. So I can also use the same equation can be applied between A and C and B and C.
Yes, sir.
So I
Yes,
can
sir.
find it out. Okay. So when you use it this way, you will get your answer. And if even you apply it between A and C, still you will get your answer. Right?
Yes, sir.
Okay.
Yes, sir. सर
So
अगर
जी
अगर हम सर अगर किसी दो स्टेट्स के दरमियान हम फाइंड कर रहे हैं जिस तरह हमने अभी स्पीड वेलोसिटी या डिस्टेंस फाइंड किए
जी
सर ये टी की वैल्यू किस तरह डालेंगे कि ये टी कौन सी स्टेट का है टी सर टी टाइम
अच्छा टी हमें क्वेश्चन में जरूरत ही नहीं पड़ी, लेकिन अगर आप फाइंड आउट करना चाहते हैं तो आप कर सकते हैं. ठीक है, फॉर एग्जांपल मैं इस इक्वेशन में टी निकालना चाहता हूँ इस इक्वेशन में. ठीक है, और मेरे पास जो वेलोसिटी मौजूद है, अच्छा मैं कौन सी वेलोसिटी मैं टाइम निकालना चाहता हूँ यहाँ पे टी बी, राइट. सो ये इक्वेशन हो जाएगा वी ए और वी बी एंड वेलोसिटी विल बी okay VA VB and this time will be final time, so this will be okay. I think I put it wrong. This one will be VB, this one will be VA, okay, and this time will be TB. Right?
Yes, sir.
So we can do it this way.
Yes, sir. और अगर सर इससे ऊपर वाली इक्वेशन में डालें थे
जी इससे ऊपर क्या,
अगर उस इक्वेशन में डालें तो फिर किस तरह डालेंगे?
किस इक्वेशन में?
सर ये जो फर्स्ट इक्वेशन है s = s0 + v0 t + ½
अच्छा ये इट डिपेंड्स. देखिए आपने क्या करना होगा, आपने पहले जो इक्वेशन में वैल्यूज चाहिए होती है आपने वो फाइंड आउट करनी होती है. ठीक है.
यस सर.
अगर किसी और इक्वेशन से मसला हल हो सकता है, ठीक है, एक इक्वेशन से मसला हल हो जाएगा, अगर नहीं है तो फिर आपने दो इक्वेशन से. फॉर एग्जांपल इस इक्वेशन को मैं किसके दरमियान अप्लाई कर दूं, ए और बी के दरमियान अप्लाई कर दूं.
यस सर.
अच्छा तो ये हो जाएगा ए, ये बी हो जाएगा, ये हो जाएगा ए. माइक ऑफ कर दें, माइक ऑफ कर दें, माइक शोर आ रहा है आपका माइक. अच्छा ये हो जाएगा एस ए और ये जो टी है ये फाइनल टाइम है, सो ये हो जाएगा आपके पास टी बी. एक्सेलरेशन हमारे पास गिवन है एंड दिस वन विल बी बी. नाउ यू सी दिस इज बेसिकली एस बी, ये हमने फाइंड आउट करना था. एस ए हमारे पास है, ठीक है, और वी ए भी हमारे पास है, यहाँ पे वी ए भी हमारे पास है, एक्सेलरेशन भी हमारे पास है. अगर हमें टी बी मिल जाए इस इक्वेशन में किसी तरीके से, ठीक है, तो हम ये वैल्यू फाइंड आउट कर सकते हैं. तो टी बी हम कैसे कर सकते हैं, इस इक्वेशन से तो कम से कम हमारे पास नहीं आ सकता. ठीक है, इस इक्वेशन से भी टी नहीं आ सकता, तो ये इक्वेशन रह गया, इससे ट्राई कर लेते हैं. सो जिस तरह मैंने अभी आपसे कहा कि अगर इसको हम बी और ए के दरमियान अप्लाई कर दे, दिस वन विल बी बी, दिस वन विल बी वी ए, ये वाला, ठीक है, एंड दिस वन विल बी टी बी. तो सारी की सारी वैल्यूज गिवन है. ठीक है, आपके पास वी VB भी आपके पास गिवन है, VA भी आपके पास गिवन है, A भी गिवन है, सो यहाँ से आप TB निकाल लें, इसको यहाँ पे पुट कर दें।
यस सर।
ठीक है, सो दैट्स व्हाई आई आस्क यू पीपल कि आप प्रैक्टिस करें, बार बार प्रैक्टिस करें, जितने क्वेश्चन मैं कहूँ वो भी कर लिया करें, इसके अलावा भी प्रैक्टिस कर लिया करें, तो उससे ये चीजें क्लियर होती है। इवन अगर इनिशियली आप देख देख के भी प्रैक्टिस करते हैं ना, तो आपको समझ आ जाता है, अच्छा यहाँ पे इस किस्म का इक्वेशन यूज होगा, ये यूज होगा, सो आपको फिर ये चीजें क्लियर हो जाती हैं। ठीक है,
Yes, sir.
ओके। अच्छा, क्वेश्चन, व्हाई एक्सेलरेशन ड्यू टू ग्रेविटी इज नेगेटिव? सो इट्स वेरी मच सिंपल। एक्सेलरेशन ड्यू टू ग्रेविटी इस वजह से नेगेटिव होती है, हम यूजुअली अपवर्ड चीजों को पॉजिटिव लेते हैं, अपवर्ड वैल्यूज को, लेकिन एक्सेलरेशन ड्यू टू ग्रेविटी इट पुल्स ऑब्जेक्ट्स टुवर्ड्स इट्स सेंटर और टुवर्ड इट्स सरफेस, जो कि डाउनवर्ड आपके पास होती है। ठीक है, एंड देन हियर आई हैव गिवन यू एन एग्जांपल ऑफ दैट कांस्टेंट एक्सेलरेशन और कांस्टेंट डिसेलरेशन प्रोसेस। वहां पे भी जो मैंने एक्सप्लेन किया था 10 8 6 4 2, तो इट्स सेम। ठीक है, वी ऑलरेडी गॉन थ्रू इट। Okay. In most of the books, especially in R.C. Hibbeler, when you go to the end of any topic, so here they what they basically do, they combine those important conclusive points from the topic or from the chapter. So the first one is basically dynamic is concerned with the bodies of accelerated motion. So even in our initial class, I have told you that dynamics can also be defined as the mechanics of accelerated body. Kinematics is basically related to a study of geometry of motion, for example, displacement, velocity, and acceleration, etc. And then kinetic is study of forces that causes motion, means the relationship between force and the different types of motion produced. Rectilinear kinematics, basically it refers to the motion which is in straight line, and speed refers to the magnitude of velocity. Average speed is the total speed traveled by the total time, or divided by total time, and this is different from average velocity, because velocity must have direction, which is displacement divided by the time. And if a particle is slowing down, its velocity is decreasing, so we will not use the word accelerating, rather than we will use decelerating word, so it will be having deceleration. If a particle means, there can be a case when we have zero velocity, but still the particle will be having an acceleration. So a particle can have an acceleration and yet have zero velocity. And then this relationship ADS VdV, this is basically derived by combining these two equations and by eliminating this dt from these two equations. Okay, यहाँ तक समझ आ गई ये सबको?
Yes, sir.
Yes, sir.
Okay, then we have this sample problem in Jail Merriam book 2-2. आप काइंडली इसको गो थ्रू कर लें, इसको देख लें, एंड फ्यू ऑफ द प्रॉब्लम्स फॉर फ्रॉम जेल मेरियम बुक वो भी आप देख लें. ओके, आई थिंक दीज प्रॉब्लम आर इजी. द सॉल्यूशन मैनुअल इज आल्सो अवेलेबल. अगर आपके पास नहीं है सो लेट मी नो, आपको मैं प्रोवाइड कर दूंगा. ठीक है, अपलोड कर दूंगा, लेकिन पहले आप खुद देख लें. एंड इट विल बी बेटर कि अगर 1-2 मिनट लगा के एक आध प्रॉब्लम को हम इसमें देख लें क्विकली. मैं आपके साथ फुल स्क्रीन शेयर कर लेता हूँ. Okay, so let me share complete screen. I hope आपको स्क्रीन नजर आ रही होगी अभी.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so let's go through kinematics of particles, and this is the example. You can go through this sample problem 2/2. Okay, so I have given you this example, this problem, this exercise problem 2/2. Okay, so in this example, what they have given, they basically, what they did, for example, they are having an equation S is equal to 30 t cube plus 10 t square plus 5t. Okay, this is an equation, for example. Okay, what you need to do, you need to plot you need to plot a graph between displacement and time. How you can plot? On y-axis you will be having displacement, on an x-axis you will be having t, and the value that you have to use, it is from 0 to 12 seconds. So the time interval, it can be 0.2, 0.4, 0.6, or 0.5, 1.5. And how you can do it? Basically, you can use Excel for it. So in Excel, you need to put time, like you put 0, then 0.5, and drag it. So you will get all those values in a very few seconds. And then in the other column, you put S. So put equal over here, write down this equation here, and instead of T, you need to select this cell. Okay, when you write this equation, pull it down, and then what you can do, you can make or insert a plot in Excel between these two quantities. So you will get a curve between displacement and time, right?
Yes.
Okay, then they will ask you to find out the plot for velocity. So how you can find out the plot for velocity? So velocity is the rate of change of, so means what you can do, you can find out ds by dt. So when you do ds by dt, so in this case this one will become 90 t square, and this one will become 20 t, and this will become 5. So plot the same equation over here, like the equation for velocity, and drag it, and then plot same type of curve, insert curve for velocity, means between this one and this one. Then for acceleration, again take another derivative. Then they will ask you to find out the time when velocity is 0. So what you can do, the velocity equation, you need to put the left side is equal to 0, and from this you can find out the value of t on the right side, right?
Yes, sir.
Okay, so now let's go to the problem.
Yes.
What they're saying in the problem. The position of particle is given by s is equal to 2t cube minus 4t square plus 200t minus 50, where s is in meters and t is in seconds. Plot the position, velocity, and acceleration as a function of time for first 12 seconds of motion, right? अच्छा, ये मैं क्यों करवा रहा हूँ ये चीजें? ये इस प्रॉब्लम में कोई है भी नहीं. एक तो आपको थोड़ी सी एक्सेल की प्रैक्टिस हो जाएगी, जो कि आप ऑलरेडी फर्स्ट सेमेस्टर में कर भी चुके हैं, ठीक है. एंड आपको प्लॉट्स का थोड़ा सा अंदाजा हो जाएगा कि प्लॉट्स कैसी होती है, और आगे फिर आपके जो प्रोजेक्ट्स वगैरह होते हैं, फाइनल ईयर प्रोजेक्ट होता है या आपकी रिसर्च वगैरह जो होते हैं, उसमें आपको थोड़ा सा अंदाजा हो जाता है कि कैसे ये चीजें प्लॉट होती है. ओके, एंड देन व्हाट यू नीड टू फाइंड आउट, डिटरमिन द टाइम एट विच वेलोसिटी इज 0. तो ये भी मैंने आपको बता दिया कि कैसे ये आप करेंगे. ओके, 2-3 देख लें. The velocity of particle which moves along the axis is given by this one. तो velocity given है, t भी given है, सब कुछ given है. आपने क्या करना है, position velocity at different times ही आपने find out करना है, जो कि अब इसी same type of question हमने यहाँ पे किया है. अच्छा, इसमें थोड़ा सा देख लें. 2.9 experimental data for the motion of particle along straight line yield this value for v at various position वर्सेस कोऑर्डिनेट s. तो ये देख लें, एक कर्व है, एक साइड पे आपके पास वेलोसिटी है, एक साइड पे आपके पास डिस्प्लेसमेंट, इनके दरमियान एक स्मूथ कर्व है. आपने क्या करना है, a smooth curve is drawn through the point as shown, determine the acceleration of particle when s is equal to 20 feet. आपने क्या करना है, अगर s आपके पास 20 फीट है तो आपने इससे एक्सेलरेशन की वैल्यू निकालनी. तो एक्सेलरेशन का तो हमें पता है कि इक्वेशन उसकी क्या है, लेट्स से वो देख लेते हैं. एज वी नो दैट acceleration is dv by dt, right? यही है ना?
Yes.
Yes, sir.
Okay. What if I divide this by ds and also multiplied by ds? कोई मसला तो नहीं होगा ना?
No, sir.
Okay. What is ds by dt?
Velocity.
ds by
Speed है सर, speed.
Velocity.
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 इसकी जगह मैंने
Velocity.
velocity लिख दिया, ठीक है? Okay. Now look at this curve. Here we have v and here we have s, right? अगर आपके पास कोई कर्व हो,
sir.
उसका स्लोप आप फाइंड आउट करना चाहें तो स्लोप कैसे फाइंड आउट करते हैं? मैथ से थोड़ा सा याद होगा आपको.
y को x पर डिवाइड करते हैं, मतलब
Y
अगर हमारे
जी,
पास
dy by dx से करते हैं ना,
yes, sir.
y को x पे डिवाइड कर दें. ओके, सो लेट्स सी, ये दो यूनिट्स ले लेते हैं. सो y में ये जो 2 यूनिट्स है आपके पास, ठीक है, इसमें कितना डिस्टेंस है?
2
0 से 2
ये 2
2 ठीक है ओके।
17
और जरा x में ले लेते हैं, x में ले लेते हैं, इसमें कितना डिस्टेंस है?
5
ये 5 हो
5 हो गया, तो स्लोप क्या हो जाएगा? 2/5 हो जाएगा।
यस सर
यस सर
yes sir
ओके सो मींस v dv/ds आपके पास हो जाएगा, ये आपके पास हो जाएगा 5, ठीक है, और वेलोसिटी।
यस सर
तो अभी क्वेश्चन में इन्होंने क्या कहा है कि डिटरमिन द एक्सेलरेशन ऑफ द पार्टिकल व्हेन s इज इक्वल टू 20 फीट, व्हेन s इज इक्वल टू 20 फीट, ठीक है। सो व्हेन s इज इक्वल
Yes,
टू
sir.
20 फीट, ये आपके पास s इज इक्वल टू 20 फीट है ना, तो इस पे जरा वेलोसिटी
Yes,
देख लें,
sir.
वेलोसिटी क्या होगी यहाँ पे?
3
3
3। अच्छा, तो s इज इक्वल टू 20 फीट पे वेलोसिटी 3 होगी आपके पास। ये तो मैंने थोड़ा सा आई थिंक 2/5, और ये आपके पास हो जाएगी 3, राइट। तो इसको मल्टीप्लाई
sir.
कर दें, आपके पास आंसर आ जाएगा। इज इट क्लियर?
यस सर।
अच्छा
सर
तो
ये इस ग्राफ
बाकी
का
जी जी,
सर ये इस ग्राफ का कर्व जो है वो तो कांस्टेंट नहीं है सर,
क्या
क्योंकि
मतलब
स्ट्रेट
कांस्टेंट
लाइन
नहीं है?
नहीं है सर,
स्ट्रेट
ये
लाइन नहीं है
स्ट्रेट
ना?
लाइन। हाँ
हाँ,
सर,
तो
तो फिर
स्ट्रेट लाइन नहीं है।
इसका
हाँ, इसका
कर्व
क्या?
तो सर वो कर्व तो फिर कांस्टेंट नहीं होगा।
कर्व तो
नहीं
कांस्टेंट
मतलब
नहीं होगा। हाँ हाँ,
हाँ इसका जो हम डिराइवेटिव ले लेते हैं y/x है, वो तो
अच्छा
कांस्टेंट नहीं
ये
रहेगा थ्रू आउट।
एग्जैक्टली दैट्स वाई हम क्या करते हैं, उस स्पेसिफिक डिफरेंशियल पोर्शन का हम डेरिवेटिव लेते हैं, dy/dx। समझ आ रही है?
यस
ठीक
सर।
है। अच्छा,
यस
ये देखें, एक्सपेरिमेंटल डेटा फॉर द मोशन ऑफ पार्टिकल अलोंग अ स्ट्रेट लाइन yield Meyer value for the velocity v of various position coordinate s. A smooth curve is drawn through the points as shown in the graph. ठीक है, क्वेश्चन की समझ आ रही है?
यस सर। हाँ
अच्छा, आपने क्या करना है बेसिकली, यहाँ पे जो मैंने इवन 20 पे मैंने जो v की वैल्यू ली है, यहाँ पे आपने मुझे 3 कही, लेकिन ये 3 से स्लाइटली ऊपर है ये वैल्यू। इज इट क्लियर?
यस
सो
सर।
दिस इज जस्ट लाइक अप्रोक्सीमेशन। और दूसरी ये जो है कि इस किस्म के केसेस में आप जब एग्जैक्ट उस पॉइंट का वो नहीं ले सकते, तो फिर आप क्या करते हैं, dy/dx यूज कर लेते हैं, जब आपके पास हर एक पॉइंट पे कोई चेंजेस वगैरह हो रहे हो। ठीक है, सो लेट्स से एट सर्टेन इंस्टेंट हमारे पास जो स्लोप है, अगर आप इसका नहीं लेना चाहते, लेट्स से जो आपने कहा, आपके क्वेश्चन को वेरीफाई करने के लिए एक और काम कर लेते हैं। यहाँ पे ऐसे कर लेते हैं, किसी भी दो दो पॉइंट्स के दरमियान इस पॉइंट का और इस पॉइंट का आप स्लोप निकाल लें। ठीक है, इसका और इसका आप स्लोप निकाल लें। तो अगर जो स्लोप हमने निकाला है अगर वो सेम है, फिर तो ठीक है, कोई मसला नहीं, लेकिन अगर वो स्लोप डिफरेंट है, सो देन इन दैट केस वी कैन हैव अ प्रॉब्लम। अच्छा, तो चले चले यहाँ से देख लेते हैं, हो सकता है ये जो हमने निकाला हो ये सही ना हो, आप इस पॉइंट का निकाल सकते हैं, फॉर एग्जांपल इस पॉइंट का। तो यहाँ पे आपके पास जो एक्स की वैल्यू हो और जो वाई की वैल्यू, यहाँ से देख लेते हैं, फॉर एग्जाम्पल दिस इज एक्स, राइट, ये एक्स की वैल्यू हो जाएगी ना यहाँ से, देखिए यहाँ तक।
यस सर।
अच्छा, तो
Yes,
ये
sir.
कितनी वैल्यू एक्स एक्स पे कितनी वैल्यू होगी है?
17.5 7.5
17.5, ठीक है। और ये जो आपके ये दूसरी जो आपके पास
2
ओके,
7.5
सो दूसरा देख लेते हैं, यहाँ पे फॉर एग्जांपल 0 टू दिस पॉइंट, ये तो y में आपके पास 2 हो गया, और यहाँ पे जो वैल्यू आपके पास
Yes,
है
sir.
17.5। यस, सो इसका जो स्लोप होगा ये आपके पास स्लोप आ जाएगा। ठीक है, यहाँ पे अगर हमने लेना है तो फर्स्ट वन जो हमने लिया था, आई थिंक दैट वाज रॉन्ग, दैट वाज नॉट राइट। ठीक है, सो आप क्या करें, इसको काइंडली करेक्ट कर दें, क्योंकि हमने बेसिकली स्लोप लेना होता है कर्व का, एंड वी वर कंसिडरिंग ओनली द डायग्राम। सो आप क्या करें, दिस वन वाज द स्लोप, दिस वन विल बी द स्लोप, दिस वन एंड दिस वन। अच्छा, फिर इस पॉइंट का ले लें, इस पॉइंट का जरा देख ले क्या आता है, 4, और ये क्या है
23.5
23.5 22.5
नो 22.2
यस
22 ठीक है। सो 4 डिवाइड बाई 22.5, सो देख लें इससे सेम आते हैं, तो ऑलमोस्ट सेम आंसर आपके पास आएंगे। स्लोप बेसिकली आपने डायग्राम का नहीं, आपने इस कर्व का बेसिकली फाइंड आउट करना। So yes, you are right. We actually neglect this point. So basically जो slope आपने find out करना होता है वो आपने curve का ही find out करना होता है. Initially we were mistaken. Okay, thank you for the correction. जी clear हो गया अभी?
Yes, sir.
Yes, sir.
Okay.
Yes.
Now let's look at ये देखें ना, ये अभी जनरल एक प्रॉब्लम था. सो इसमें ये चीज क्लैरिफाई होगी. छोटा सा मिस्टेक था, लेकिन इस छोटे से मिस्टेक की वजह से एक्चुअल केसेस में बड़े प्रॉब्लम हो सकते हैं. सो 9, 13, 14, 15, 18, 35 ये रिमेनिंग आप काइंडली फिर खुद ट्राई कर लें. ठीक है, ये मुख्तलिफ किस्म के प्रॉब्लम्स हैं. सो यू काइंडली गो थ्रू इट. इसको आप सॉल्व करने की कोशिश करें. एंड आई होप कि अगर आप इसको सॉल्व करेंगे सो you will be in a position to solve problems in your exam. Okay, so if you are having any
sir.
question regarding today's class, you can ask. If you don't have any question, so फिर मैं recording off कर देता हूँ. Off कर दूँ recording?
Yes,
sir.
sir.
Yes, sir.